So here we are, question 86 now, transforming the graph of sine x. So the first thing I'm going to do is to remind myself what the graph of sine x looks like. So there's sine x, and we've got the maximum value of 1, the minimum value of -1, 180 here, and 360 here. So let's have a look at the first function then. So there's f of x. So what's happened is that the figure here, which would be normally at 90 degrees and 1 up, has the y value is increased by 1. This point here, 270 minus 1, has also had the y value increased by 1. So effectively the graph of sine x has been shifted up by 1 unit. So we express that as translation by the vector 0, 1. The 1 is in the y direction there. And that's the only transformation. Then the function notation for this is f of x equals sine x plus 1. So let's have a look at the next graph. G of x now. Now what's happened with g of x is the point that would normally be here, which is 91, has been changed to 45, 1. And the point that would be here, 180, 0, has gone to 90, 0. So the x values have both been multiplied by a half. So that's what the transformation is. The stretch by a scale factor of a half parallel to the x-axis. And in function notation, g of x is sine of 2x because it's inside the brackets. That's the effect of affecting the x values, and multiplying the x by 2 has the effect of stretching the graph by a scale factor of a half. What about the next graph now? So slightly less obvious perhaps. What I'm looking at to start with is the y values, 3 and -3 here. So the gap between the top and the bottom is now 6, whereas normally on the graph of sine the gap is 2. So we seem to have multiplied the y values by 3. But that's not all, because the graph, if we just multiplied this by 3, then the graph would go through the origin. It looks to me as if the graph has been also shifted to the left by 90 degrees, and that's confirmed by the normal figure of 270 here is now 180. So what we've done is we've done two transformations: a stretch by scale factor 3 parallel to the y-axis, and then a translation by the vector -90, 0. So in function notation, that looks like this: 3 sine x plus 90. Now, does the order matter? Well, the answer is no, because this transformation is affecting the x values, this is affecting the y values, so they're independent of each other. Let's have a look at the fourth graph. So looking at the y values first, we've got 3 here and -1 here. So the gap between the two, the maximum and the minimum point, is now 4. So we seem to have stretched the graph in that direction by a factor of 2. So what else has happened here though? The y values are, the x values are as we would have expected, 270 there and 90 there for the minimum and maximum figures. But we seem to have translated the graph up as well by 1 unit. So that means we've got two transformations. One of a stretch by scale factor 2 parallel to the y-axis, and a translation by the vector 0, 1. And the order now does matter, because both of these transformations are affecting the y values. So that's why I've said then indicating that there's an order. The function notation is 2 sine x plus 1, again reinforcing the fact that the 1 plus 1 is affecting the y's, and also the 2 is affecting the y values as well. So how did you get on with that one? That's the way I answered the question. I think there are probably other ways of doing it as well.